Hello, everyone. I'm very happy to be here. This is my first time in the area, and kind of capping off, I've been traveling around this actually last 3 months since I've been at Cadence. So after this trip, which includes 4 countries, I hope to go home and relax for just a little bit. So today, I want to talk to you about something that's been bothering me for some time. I was asked, I guess, back in September to present at this event, and I said, within Cadence, I said, okay, what do you guys want me to talk about? You want me to talk about some kind of cool Cadence tools or flows or something like that? And I hope not, because I just joined, so I don't really know too much. Luckily, they said, no, you can talk about whatever you like. So what I like and what I don't like, actually, is that I sense in today's verification that we may have lost the plot a little bit. There were some discussions, I think it was Will and Simon earlier, we mentioned some things about looking at the post-silicon results, looking at reducing the number of bugs, these sorts of things. I sometimes wonder if we don't get too caught up in the verification-ness of what we're doing. We're so excited about our jobs as verification engineers that we forget that verification engineer is not really the point of what we're doing. It's just a thing that has to get done. It's part of a role that we need to play. So what I want to talk to you about is some rules and behaviors. Actually, I might as well go. So we talk about kind of what the mission, I think what we all might agree to be the mission of verification, and then what I actually think it is instead. Then I'm going to talk about rules and behaviors, things that I think, now maybe not, maybe, I don't know, but a lot of teams in my consulting experience when I was at Verilog before I joined Cadence, a lot of those things, I noticed teams, they think that there are parts that are rules. Okay, here's something that's a rule, right? Well, we should follow that rule. Is it really a rule, or did you just make it to be a rule? Is it an absolute thing, or is it something that you can modify based on the situation? Kind of an analogy is, if you're doing place and route, you might be trying to place and route the design, and it may not work very well, and so you might try a different strategy. There are different strategies that you can try, and you have to know there are strategies, and the strategies apply in certain cases. You don't always use the same strategy for the same purpose. So we'll talk about these things and kind of the summary of that. How many of you would agree that this is the job of the verification engineer? Now, I've previewed it a little bit, so maybe you say no, but this seems reasonable, right? Find as many bugs as possible. Why wouldn't you want to do that, right? There's another formulation of this which I think is a bit different but more precise. And we talked about it earlier. What we really want to do is, as a project team, we're trying to deliver a chip to customers that has as few bugs as possible. You can find as many as you want. We talked about, I think earlier, if there's too many bugs, of course, if the bugs are just in the design, you could find a whole bunch and there might be a whole bunch more. So just finding bugs and acting in that way as a verification engineer is not enough. And if that's all you're doing, I'll claim that you're not doing a job. So let's talk about these rules and behaviors. So there's 5 rules, 5 behaviors, and let's go through each one. And let's see how they might be used in today's environments and how we might want to make some modifications. So, classic rule of verification, right? A lot of teams say, look, you need to have separate design and verification. How many of you do this in your company, separate design and verification? I was going to say, I need some hands because otherwise it's a flat lie. So, okay, all right. And now, how many of you have the design and verification teams geographically separated, whether in a different building or in a different place? Anybody? I know that actually happens as well, so yeah, there you go. So, part of it is because of, outsourcing and various things that go on in the world today, but really that a lot of this stuff happens because there is this thought that if you have the designers and the verification engineers working together, you're going to get this thing which I recently heard called the teamwork bug. Right? You guys know what it is. You're sitting, you're talking away with the designer. You decide this feature works just great, and lo and behold, that you agreed upon the solution but was not actually correct. The chip goes out. Oh, actually, I forgot. We decided none of you had post-silicon bugs, right? So this crowd has no such problem. But in general, this could happen, right? And you know, you want to let the designers and the verification engineers do what they do best. So the designer can focus on their part. The verification engineer can, you know, they've got all this great knowledge. They've taken a great Doulos training course, and so they know about object-oriented programming and how to do sequences and all this stuff. So let's keep them separate and let's let them work independently. But there can be problems with this. So sometimes that's a really good idea. Sometimes, though, there may be problems. You know, today's designs, actually, everybody says today's designs are complicated. They've always been complicated. You know, I had a chance to talk with, there's a guy by the name of Pat Pastilli, who's the founder of the Design Automation Conference in the US, and in the 50s he developed this idea of EDA. And he's telling me about how they would build these giant big boards that have like 6 giant big transistors on them. And they would put these boards in this giant big boxes, and they would spend months and months, they would draw up schematics for these, and they would spend months and months and months trying to debug them on paper. And then they would put them in the box, right? I mean, that's hard. I mean, yeah, 6 transistors, we're thinking, wow, that's not so hard. But it was hard at the time, so it's always hard. But, you know, if you look at what we're doing today, if you're going to really separate the designer who has the domain expertise from the verification engineer who knows how to test these things, then the verification engineer may not have enough design knowledge to do the testing. There was a case, I think a bug was mentioned earlier about this FIFO, that if you hit a certain case, the FIFO overflowed, and you couldn't hit it from your block level testing. The question I would ask is, did the verification engineer even know there was a FIFO in the design? If they didn't know it was in there, they sure as heck weren't going to try to test for it. That FIFO may never have been in the spec. It might just be an implementation detail, not visible from the outside. You need to know about these things, okay? Another thing is sometimes, and I don't know about here, but some places in the world, the verification engineer is a little bit less senior than the design engineer. Sometimes that's, you know, they take the new engineers and they put them into verification thinking that this is a great way for them to learn. And that's probably an interesting topic of debate. Maybe we can talk about it later. But if the engineer is more junior, then you're going to basically put them in a situation where they don't know what's going on. They have to do this thing. It's going to take them ages to learn about this topic. So sometimes separating design and verification, sometimes it's good, but I think in moderation, sometimes it can be a disadvantage. Here's another one. Verify what the designers give us. Sounds kind of weird. You're thinking, okay, yeah, so the manager told me, I should check, by the way, are there any designers here? Anybody who's a designer? Okay, cool. Anybody who's a manager? Okay, and the rest of you, verification engineer? Yes? Anybody I didn't call? Okay, yeah. So some off random folks. So hopefully, well, we're going to ask them what they do later. So verify what the designers give us. Trying not to curse too badly, which I'm prone to do in my normal speech. You know, no crap. So we get a spec. We take the spec. We verify the spec. We make sure that the design works as the spec says it should. That could work if the spec was complete. How many of you guys get specs that are complete? It must be really bad here for verification. You guys are very subdued. Hopefully it's not so bad. So the spec is rarely golden, right? So if you rely on that spec, you're already screwed. Okay. Second thing is the designer's job is to create this wonderful system of beauty and magnificence. And verification engineer's job is to destroy that system piece by piece and make the designer cry. That's how I take it anyway. Maybe that's why I'm not so popular when I'm on the verification team. But, you know, you have to think about it. If you don't understand the use cases of the system, the use cases of the customer, and let me ask a question. How many of you guys would say you know what the customer wants the product to do? How many of you would say you have no idea what the customer wants the product to do? Let me rephrase. How many would say you have less of an idea? What about software? How many of you guys are working with the software team? How many of you guys don't know who the software team is or who the people are or never seen them? Yeah? I had so I'll talk about that in a minute, but basically, if you rely on what the designer gives you, you're going to be setting yourself up for failure. So again, you assume we should verify what we're given, but if you're doing your job as a verification engineer, you need to take it a little bit further than that. You can't be satisfied. Oh, here's a fun one. So SystemVerilog and UVM Anywhere, maybe UVM, Easy UVM Everywhere, maybe. Now I was on the UVM committee for 4 years, so I know a little bit about the UVM. And hey, it's an industry best practice. We had these great experts working on this library. You know, the tools support it. This is so what you should do is you should actually start changing all of your test benches and environments. You want to make sure that all the way from the block level to the cluster level, the system level, you're taking advantage of this wonderful new technology that we have. And that actually is, I mean, does that come up in your companies? I don't know. I mean, a lot of companies, the manager comes in and says, hey, we want to use industry standard techniques, and the EDA guys like myself now apparently say you guys should use industry standard techniques, and it's really good. Is this normal? Yeah? So why wouldn't you want to do this? Well, as John said earlier, using the UVM and SystemVerilog, this also applies with the E, with UVM, requires specialized knowledge. So designers are a simple lot, right? They don't always understand these advanced software techniques like 20-year-old object-oriented programming. And so it's difficult if they have to use this test bench, or if a software engineer needs to somehow use your test bench, this is a problem. You also may find that if you're trying to use this at the full chip level, it's too slow. I mean, putting in a full UVM test bench at the full chip level, you know, it may be better just to be doing some directed tests or some special use cases at the full chip. And another thing that you might want to do is you might want to have a system whereby you can write some tests, take them from your block level test all the way out to FPGA or prototype or the full system. UVM may or may not be the best option for this. So you shouldn't feel compelled if you're getting this message that UVM is great. It is very useful. If you're using SystemVerilog, you better be using UVM. But it's not the end-all, be-all. Remember, the point of our project here is not to write a cool test bench. The point of our project is to have a chip with as few bugs as possible. Functional coverage. Now, that's a good one, too. Functional coverage is awesome because managers like metrics. They really like metrics, and they really like to see that you're almost done. Even if you're just almost done with the part that's not yet, you have a missing piece that you're not showing. So you're almost 100% done with the part that you've done, which is not the whole thing. But they still like to see it. But actually, it is very good, and I am a big proponent of tracking your metrics and having an executable verification plan, because it is nice to see automatically that your simulations are doing what you expected them to do and that you're covering the things you expected to cover. The problem is, at the very end of a project, you have to watch out because you start to arrive at the situation where, and maybe this has happened to you, there's something that you'd like to cover and you'd like to show this coverage metric being 100%. But there's some little piece, and it's really weird, and you can't figure out how to represent this in your coverage model. So you could choose at this point to spend 6 more weeks and represent it in your coverage model, but is that the best use of your time? So this is the engineering judgment, I think, that was mentioned earlier. Is it the best use of your time to spend it on that? Now you have to decide. It might be, but it possibly is not. And in which case, you know, you could actually do such crazy and wild things as reading the code. You know, you could look at waveforms, although how many of you would ever recommend looking at waveforms as a way to test your verification? Just curious. You would look at waveforms, yeah. I went through a phase. I think at first I thought it's okay. Then I thought it's from Satan. But then, I mean, if it's going to take you 6 weeks and you can just pull up a waveform and look at it, so you can tape out tomorrow, think about it. Use your common sense. We're smart people here. Well, I mean, I don't know about me. You guys, I'm sure, are very smart. So you can do this, right? You can make the judgment. You have the expertise to do this, so don't feel compelled. This is kind of the theme of this presentation, right? You shouldn't feel compelled to continue with these activities just because you think it's the proper way. Now, here's another one, which is kind of a simple rule, and I actually am a big proponent of this. separating your drivers and monitors. So how many of you are building agents in your UVM test benches? Okay. So common sense, right? You should have a separate monitor and a separate driver, right? And the monitor should be able to be used independently of the driver, because if you do that, you can use it as a checker in your full chip, or you can use it as a checker elsewhere. I've had words with people who don't do this. I've had very heavy arguments about this. But again, there are some cases where this might not be appropriate. For example, if you're building an SoC, and on the edge of the SoC is a top-level interface, maybe it's PCI Express or something similar, and you know that that interface is, for your project, always going to be at the top. You also know that it's crazy complicated. Maybe you shouldn't spend 6 months writing a special custom monitor and driver for this. I think it's generally a good idea. I could probably throw in here that you should really, in that case, buy a Cadence verification IP, but I won't do that, so don't worry. So this is again, yes, might be definitely a good idea. It's sometimes not a good idea. All right, now behaviors. These are things that you may not realize that you're doing, but you're probably doing anyways. When you're going to root cause an issue, here's one. How many of you would be to say that your bugs fail in your regression? The verification engineers are typically the ones that take a look at those fails to see if the root cause, what the problem is. The rest of you are lying, right? It's true, because I know that's what happens. When you root cause those issues, how far do you take it? We heard earlier that there were only 2 causes of bugs. I don't know what you guys think. Would you say, how often do you go back and actually try to find a root cause that's past the verification team? Who would say they go further past just the verification team? Like a verification team root cause would be the test was not, this feature was not tested. This is the classic verification engineer cop-out root cause of a bug. Yeah, we didn't test it. Wow, that's brilliant, right? Of course you didn't test it. If you tested it, it wouldn't be broken. Actually, that's also not true. It could still be working if the designer hadn't put the bug in the first place. I mean, really. So the designer screwed you, and you're not even willing to go back and screw them back, right? You're not willing to go and find out where the fault really is. Verification engineers, they always come up with these stupid, I'm sorry, but it's stupid root causes. We didn't put coverage in. We didn't write a test case for this. Okay, the root cause is probably something different. It's probably something like the architecture of the design changed a month into the project. Designer A saw the change, changed his block. Designer B did not see the change. The 3 sentences changed in the middle of a 1,000-page spec. Did not see this change. He did not fix his block. Then designer C went and changed designer B's code without ever telling anyone, thus exacerbating the problem. That's nothing to do with verification. And none of those things are to do with verification. If you stop at the verification root cause, you can't remove the source of the bug. And remember, we want to, if I find 5 bugs in a whole project, I'm happy if no bugs are found by the customer. I want the bugs gone from the start. So we need to do this root causing. We definitely need to have different people involved. We need to have software engineers. But again, some of you don't know the software engineers, right? In my consulting activities in the past, I've had great fun. I was working with one client in a safety area. This is a safety area. And they had separate design and verification, so they had that going for them. And then they had basically, I said, well, have you talked with the software team to see how these features work? Because they had one of these awesome specs. Maybe you've seen them. Requirement number 1.7.342, and then a sentence. Require 1.7.343, and there's like 1,000 of these, and each one of them is important apparently. So they had all these requirements, and they felt that they'd met them, but I asked them, well, do you know what it means? You know, it's a hand thing. That's what it means, right? I'm like, well, okay, so where's the software team? Do you know them? Oh, no, we don't know who the software team is. Well, they must be far away. Yes, they're far away. Where are they? they're downstairs. So we actually had a 2-hour meeting to introduce them together with me there, which had to get a director approval, and we spent the whole 2-hour meeting talking about why we should be meeting. Just interesting dynamic, but this happens, right? You guys have seen this, it happens. We want to remove the source of the bugs in the underlying process. That is the most important thing. If you don't think your job as a verification engineer involves going back to the designers and working with them to improve the design to remove the bugs, you've missed the plot. Honestly. Now, I know that there are people who do this, so I'm not actually claiming that we're all, I mean, I'm as guilty, right, as this. And it's tricky. There are reasons why this is hard, but if you're not working with the designers as a team, you can't fix the issues. Your bugs, your problems will always get worse. You'll do as much verification as you can on a buggy code base, and you'll wonder why it's so terrible. It's because you didn't fix the source of the problem. Okay. So here's a situation. You're sitting there happily, having a coffee, waiting for your regression to run because you haven't implemented the 10x regression fix yet. So you have time for your coffee, which is kind of nice. But then the pesky manager comes by and he says, yeah, hey, listen, so good news and bad news, right? Good news, we were going to shut down the site here, but, or bad news, we're going to shut down the site here. But good news, we've got this great customer, and as long as it's November, right? As long as we deliver this full chip, which we've never done before, in a new process node, as long as we deliver this by March, we're back in business. Good news. It's kind of good news, and it's kind of bad news, right? If you think about it, there's always business reasons for these things. So there are real business reasons for why these things happen, and we shouldn't underestimate them. In my experience working with executives, sometimes you can start to see sometimes the other side of the picture that we don't always get to see as a verification engineer. But here's what tends to happen. So the verification engineers go off. Maybe you've seen this. Maybe you probably haven't done it, but maybe someone else has. They go off and they say, okay, well, we have to finish by March. So we've got these 100 things. They're all very important, and we need to finish them all by March. So we know there's, so December, January, February. There's like 3 or 4 months, let's say 4 months before we have to finish this. So we know how long each task will take because we only have 4 months to complete it. I hope you guys aren't looking at me because that's the normal thing. Because you see the problem, right? You've just looked at the situation. Okay, have you ever seen one of your colleagues or someone else do this? This used to happen to me when I would be contracting, and it's bad when you're a contractor because what can you do? You have some crazy guys like, yeah, I could do that in like a day. Like, dude, that's like 3 weeks. Oh, no, you just don't know what you're doing. And then they assign it to you because you don't know what you're doing, as opposed to the guy who said he could do it in a day. So this happens, right? And you can tell them yes. You can say, yes, here it is. The manager's totally happy. Oh, my God, great job, Joe. You've saved the project. You've come up with a schedule that meets the requirements of being done by the time that we are supposed to be finished. Great. Bonus for you. So those are all reasons. But there's another one, too. Some managers, and even some engineers, I think, have this idea that, well, look, this team, they're kind of a bunch of slackers, right? So if I tell them the real date, they're just going to miss it. But I have a good idea, right? I'll tell them a sooner date, and then they'll work really hard. They'll be late still, of course, but they'll be sooner late. Their late will be early compared to the previous late. You can only imagine the amount of alcohol that must be consumed during these discussions for this to make sense. But there it is, right? And it's terrible. Have you guys had this happen to you? It's terrible. You feel awful, and you work on this project, and you're working for months, and you're staying up late. My experience, anyways, that can only happen to somebody once before they become completely disenchanted, and they'll never work hard again. This engineer is now ruined. They're like, well, again, sorry, I'm censoring myself here. I don't know how appropriate, but some curse words come out, and they're like, yeah, what's the point? I don't even care about the schedule anymore. There's no point. Okay? That's a terrible thing to have happen. So now on one hand, here's the thing. This actually might be fine to do this if you know how to prioritize correctly. So if you go back to your manager and said, I have 100 features, but I can only get, by March, I can get done 30, but these are the 30 most important, and if we can do this, we will meet the base customer requirements. That's actually a really good way to do it, because you can get done by this, you can get it, there's a schedule, and you maximize what you can deliver by that point. Okay? But if you don't do this, all you're doing is eroding trust between the project stakeholders. So the manager then will always say, those guys told me they could do it. I know that I was going to punish them severely if they didn't tell me they could do it, but still they told me, and still they're late. So I can't trust anything they say. So next time they tell me when they say, it's going to take too long, they'll just not believe you, right? And vice versa. You don't believe the manager. They told me it had to be done by this time. This is a bad dynamic, I think. I don't care for it. And if you set up, again, customers are the most important thing. So if you all of a sudden you're delivering late to customers, you erodes trust. It's happened yesterday too, did you get the time? It's like, do I trust him? I don't know. Okay, I'll keep to that schedule. Yeah, he's applying a schedule to me without finding the prioritized requirements. So again, if you're late to customers, then they won't trust you either. Now they're pissed off and they want to know more, and they're going to start pestering you, and then you have managers coming into your meetings. And have you ever had one of these cool meetings where they're like, I know, the manager's like, I know, I'm going to go to the meeting, and then it'll go faster. And then his manager's like, hey, I've got this awesome idea from when I was that manager. I'm going to come too, because when the second manager comes, it's even better. And then the third manager comes. And so you've got like 3 or 4 managers giving you motivation on how you should finish by the date which you can't possibly meet. This is my favorite part of being a verification engineer. Okay. Here's one. And I should probably pick up a little bit here. Trust designers and protocol architects as protocol experts. You guys, I'm assuming you guys work with some very intelligent people, and yourselves included. How many would say you work with some really good design engineers? There are some really good design engineers. And some of these guys have been working on the protocols for a long time, because once you learn a protocol, why would you ever want anyone else at the company to work on the same protocol? So ideally, you should have the same person working on the same thing for like 10 or 15 years. So they really do know what their stuff a lot of times. And it's kind of a bummer if you're always having to question. So sometimes it's nice to just say, look, this person's been doing this for 10, 15 years. I'm going to just rely on their expertise here, and I'm going to go for that. The problem is, even in that case, this person might be a world expert with 20 years of experience on a protocol. They might be on the standard committee. They might have been in every meeting, and they know every nuance. Even then, you shouldn't necessarily trust them on how the design should behave. This is tricky, because they might actually be right. A lot of times they might be right, but maybe there's a situation where there's some kind of a clock domain crossing issue in this protocol. They may think of a way to test it, and it could be possible that you say, I'll just, the way they suggested me to test it, I'll just do that. But, you really need to put some thought into it, because, again, they could be wrong. So, yes, trust them, but also no, don't trust. And then verification requires specialized skills. So we've all kind of become very proud of ourselves, I think. Very awesome. Again, we've taken the Doulos training course. We have our certificate. We've been to all the cool Cadence and whoever else's presentations. We know everything. We've used these things. We know all about object-oriented and aspect-oriented and continuous integration and source code management. We're like, we're gods. We're verification gods, goddesses here. So you have all these skills, and so you think, well, the designers, they're come on. Look at these guys. They don't bathe. They come in weird hours. They look kind of crazy, and they always talk in terms of, like wires and state machines and flops, and, timing paths. So why should these guys do that? They're 2 different things. You have to have a specialist. So you could imagine, though, that if a designer is trying to design their design to be easy to verify, it is possible, in fact, very highly probable, that they're actually, how will they know how to do this? I mean, think about it. So they've never verified anything in their life. You're asking for their help to design something that's easy to verify. But they don't know how because they rely on you. Similarly, you're being asked to verify a design, but sometimes, anyways, verification engineers are afraid to understand the design code or how to design or the problems designers face. So when you're trying to come up with a verification plan, how do you know how to do that? Because you don't have the skills in design. So they don't have skills in verification. You don't have skills in design. And then we say, hey, let's add lots and lots of verification engineers to the project that will surely make the quality better. But it's interesting to consider that, in fact, the specialization could be making the quality worse. It's interesting to consider. So it's useful to have the two teams understand each other and be able to do, the designer should be able to do the verification tasks, and the verification engineers, where appropriate, should be able to do some design tasks. It shouldn't be completely outside the question. So, again, there are specialties and also, again, useful to combine. And I think, we're almost done. I might close. Okay, the last thing. All things are created equal. What I mean by this is, I explain it by example. So a couple of years ago, I was at a project speaking to an aerospace company, and I was talking about prioritization. Manager stands up and says, yeah, but we're working on this government program. The requirements are mandatory. All of them are mandatory. We can't skip any. Do you guys ever have this happen? I mean, are any of you working in this kind of areas where they're really, you have to, because they're by like some law, some crazy person made a law. They have to all be there. And what I said to him is, well, okay, that's fine. But if you actually, are you really? Maybe one of these requirements means that if it doesn't get met, I'm going to get blown to pieces. That's a bummer. I should test that one. The other requirement, also important, says if it fails, I'm going to break my arm. That is also a bad thing. But if I have to choose, I will make sure it doesn't explode first before I make sure it doesn't break my arm. There's always a way to prioritize these things. So if everything is a priority, nothing's a priority. Takeaways. Remember the mission. Ship with as few bugs as possible. You don't have to be awesome and studly or girly or whatever you would say here. I don't know. And find all the bugs, or find as many bugs. Just no bugs. We want no bugs. Few. Understand how verification works, but don't be afraid to challenge the status quo. And finally, just again, remember the difference between absolutes and best practices. And my favorite quote, or one of my favorite quotes, I have a lot. In theory, there is no difference between theory and practice. But in practice, there is. Thank you.
Thank you. Any questions? Any questions at all? I've got one question, as always, Joe. If verification engineers should know about design, aren't you just making our resourcing problem harder?
The resourcing problem, because you have to have resources that know about both. It's a good question. I used to think that you should have very separate design and verification engineers. But more recently, I've started wondering if the lack of understanding of verification engineers for design and vice versa is a problem, which would really mean to fix it, you'd have to have some more, well, cross-training is one way. You could also do it by finding tasks that the designers can do that are appropriate for their background. White box testing, assertions, you write the test bench, let them write the tests. These are all things designers can do. And the verification side, I mean, go in the code, debug the code, figure out what's wrong, come up with a solution. Why not? You can do it. I mean, why wouldn't you? So I don't know if that answers your question, but.
Yeah, I guess, like we spoke yesterday, they seem to be doing this more and more in software, especially in Agile.
Yes.
Maybe, yeah.
Right, because in Agile, you want to have most of the people on the project team have similar backgrounds so that you can easily assign the work to different engineers who are available. right? But in our teams, when I've tried Agile before, the problem is you have these people who are highly specialized, and you can't just easily ask the designer to write the complex test bench. So that's a problem. And yeah, to be solved.
To be solved.
Yes.
Watch this space. Okay. Oh, there's a question, Chris. Oh, and yeah.
So I enjoyed this, and I agree with about 99% of it.
Not 100?
Where I didn't agree was actually the first slide.
The first slide.
Maybe the same slide. So you're talking about whether it's about finding lots of bugs or having, yeah, that one. And the word that's missing for me there is risk.
Ah.
Verification is about the risk that the design will not work, minimizing that risk and quantifying that risk to the management so we can make sensible decisions about when to take out and when not to.
It's true, but if I added the word risk, it would wrap around to the second line.
Aesthetics.
Change your font.
Okay, so I agree. You're right. That's a very good point. Thank you for bringing it up, because you're right. You want as few bugs as possible, and you want those bugs to be of the kind that are not important. You would like, as we said with the, getting it blown up versus breaking your arm, you want to understand the risks so that the things that are broken are less risky. That's your point. That's what you're saying, right?
That's the point. And quantifying that risk so that the business can make the right decision about when to take out and when not to take out.
Absolutely. Now, how do you typically quantify the risk? I mean, I know there are so many ways to do it, but I'm curious how in your company you guys.
I make it up and hope nobody's looking.
You make it up?
I make it up and hope nobody's looking. No,
yes.
It's about coverage and metrics and all that kind of. That's the only tool I have.
And have you been able to check to see whether what you have done and the risk that you decided at the beginning, or maybe ongoing, how well it mapped with the actual result at the end?
Not in my current company, my previous company, I didn't have any silicon errors that I would then look at and feed that back into the process. So you can do that kind of thing.
Excellent point then. Very good.
Okay. So put risk in there.
Yes.
You've got someone there, Will, by the way.
Just a small point here. We talk about design, we talk about verification, but then who verifies the concept? So what we have seen previously, or at least what we're seeing now, is we're including verification in concept and design discussions as well. Because the verification engineer thinks in terms of finding issues, and we can find issues in concept right from stage 1 rather than finding it stage 10 when we actually get to verification.
Yes. So this is a little bit, I didn't really, you've made this is related but not the same point, I think. What you're saying is the verification team, if I understand correctly, should be involved at the beginning of the process.
Maybe not the entire team,
yes.
But one person who's leading the verification project.
Now,
that's what
do you find now. Do you find this that you guys are able to do this at your company?
We've just started, and at least there's been a request from the concept and the designers to include me in the verification lead in the project, because we tend to think in terms of breaking things, and it's good for them to know how it can be broken right at stage 1 rather than finding it broken at stage 10.
Absolutely. Which company are you with?
Infineon.
Excellent. There we go. Now where to buy our chips from next. That's great. Fantastic.
They call it shift left in software testing.
Sorry?
They call it shift left in software testing, where you're trying to shift all the verification to the beginning of the process.
Yes, exactly.
Okay.
Actually, you're talking about UVM and the drive for that from managers, but actually I find it's much more from the people coming up in the industry who are like, they see this new thing that they must learn. And actually managers would much rather you just used all your old stuff, just ran all your old tests, and they didn't have to write anything new. But, at some point everybody's going to have to go to UVM because that's where everybody's going, and you won't be able to get any new engineers who can't speak this,
Does everybody agree with that? So the point, let me see if I understand. You're saying that the managers would rather, first thing, managers would rather you keep doing what you're doing because it's kind of newfangled, or they're comfortable with the previous way.
Well, if you had 20,000 tests, if you have to rewrite them in UVM, that would probably a huge big delay in your project. The managers don't want that. They just want you to be able to run your 20,000 tests and just say, yeah.
Oh, yeah. No, I agree. So that's the first part. The second part is new engineers are the ones driving the push to UVM because and the third one being, I'm just trying to summarize quickly, the third one being That if people don't learn UVM, then, or if you don't switch, then you won't be able to hire anybody.
Ultimately, yeah. The whole industry seems to be going to UVM, and you won't be able to get engineers who aren't trained in UVM methodologies.
Because so does everybody agree with those points? No. Wow. Okay.
We're running short of time, because maybe we can move that to the EDA panel at the end, because there was a good discussion, especially at system level, for example.
Yes. If I could just leave one thing.
Yeah.
You guys, I guess it's not possible to train engineers, right? We don't like to train new ones. Just like conservation engineers, there's only a limited number we are allowed to have. No, that's not against you, but I wonder sometimes why the managers don't want to train.
Okay. Brilliant. Thanks, Joe.
Yep.
Thank you. Thank you.